So we're starting here, section 3.1, talking about ways of solving quadratic equations. So starting out on page 113 here, starting with the simple ways we can solve quadratics. We're going to use three methods, graphing, factoring, and by taking square roots. So the first one here we're going to solve by graphing. So this is going to be solved similarly to what we did with the absolute values. We're going to graph the left-hand side of the equation as one function. We're going to graph the right-hand side as another. So that means we should have a horizontal line up here at 16. So now we are dealing with the quadratic this time. So keep in mind the quadratic also has our vertex at 0, 0. And then as we think about some other coordinates we could have, so whatever the x value is, the y value is going to be that squared. So we'd have the point 1, 1. We'd have, since this is going by twos, we'd also have the coordinate 2, 4. And then since it's squared, we also have negative 2, 4. We'd also have then the coordinates 4, 16 and negative 4, 16. So if we're looking where does our quadratic intersect that line at 16? Well, that's at the equation, or at the points of x is negative 4 and x is positive 4. We can also solve this by factoring. So this method has us rewrite the equation so that 0 is on one side, and then we'll use the difference of squares to solve it out. So we have our equation, x squared equals 16. We'll subtract 16 from both sides, set it equal to 0. And then we have the difference of squares. Since 16 is a perfect square, you can say x plus 4 times x minus 4 is equal to 0. From here, if either of those products is 0, the whole product would be 0. So we could say x plus 4 is 0 or x minus 4 is 0 to, again, get our solutions x equals negative 4 or x equals positive 4. So the last simple way is going to be by taking square roots. So if you recall, a real number is a square root if that number squared is equal to the number we're looking for. So it's important to know every positive number has both a positive square root and a negative square root. So for instance, the square roots of 9 are plus or minus square root 9, which then simplify to plus or minus 3. So here we have our equation, x squared equals 16. So if we take the square root of both sides, square root of x squared is just x, and that would be equal to plus or minus root 16. And as we should already know now, the square root of 16 is 4. So our solution would be plus or minus 4. So which of these methods would be best to solve for x squared equals 5? Well, it's probably best to use the square root method, because if we do the graphing is just going to give us an approximation, and we can't use the difference of squares, so that means our solving for that as 0 is out, so that means just taking the square root. So that means our solution be x is plus or minus square root 5. Can the equation x squared equals negative 9 be solved by any of these methods? Well, no, because we can't take the square root of a negative. We can't take the square root of a negative. Okay, so moving on. Now there's a couple of properties that go along with square roots. Hopefully these are familiar to you. So the main ones we're working here is the product property of square roots and the quotient property. So what this is telling us is if we have a number under our square root, we can break it up into different products. So for example here, they had square root 12. Well, that's the same thing as square root of 4 times 3. So we can break that product apart into square root 4 times square root 3. Reduce from there, the square root of 4 is equal to 2 times the square root of 3. Now, they didn't include it there, but these will also be plus or minus answers in front of there as well. The quotient rule. So the quotient rule is the same thing. If we've got a fraction under our square root sign, we can break it up into two different fractions and simplify as needed. Now, this may require the additional step of what's called rationalizing the denominator. So we do not like to have square roots in the denominator. They're not rationals. So in order to rationalize it, we take whatever our fractional square root is here. So in this case, they had root 2 over root 7. What we'll do is we'll multiply by root 7 over root 7. Root 7 over root 7 is equivalent to 1, since you're dividing something by itself. So we're not changing our value at all because we're multiplying by something equivalent to 1. But this is just going to change what it looks like. So in the numerator, we'll have root 2 times root 7, which is the same thing as root 14. So then we have square root 7 times square root 7, which is square root of 49, or just 7. So anytime you have a square root in the denominator, you will need to rationalize, because we do not like having square roots in the denominator. So if we want to start solving some of these quadratics by taking square roots, so first thing we do, we have to isolate our x squared term. So we subtract the 16, divide by 2. So you'll find that x squared equals 8. So when we break that down, we get plus or minus root 8. You often see me when we do these in class. I like to break it down into factor trees. So when you do the factor tree, you're always looking for perfect squares. Or if you break it all the way down, you're looking for any time a term occurs twice. That's when you can pull it outside of the square root. And if it occurs once, it has to stay inside. So here our answer would be plus or minus 2 root 2, because we have a pair of 2's being multiplied, so that can come outside. And then the root 2 has to stay inside the square root. So if we wanted to try another one, okay, first step, again, we have to isolate that x squared term. So we need to subtract 9 from both sides. Then we'll have to divide both sides by -5. So in doing that, we'll get -9 divided by -5, which would get us a positive 9 over 5. So now we have to take the square root of both sides. We can use our quotient property to break it up into root 9 over root 5. Well, the square root of 9 is 3. However, we still have that root 5 in the denominator. So this is the time where we'll need to rationalize. So we'll multiply by root 5 over root 5. So that's going to get us 3 root 5 over just 5 in the denominator. So that is our simplified answer. And we'll do one more here. I guess this one more page. So again, isolating our squared term. So x squared is going to be 24. We take the square root of both sides. So x is plus or minus root 24. Again, you'll often see me drawing out these factor trees. I know this is the product of 6 and 4. Since I've got a 4 there, I can pull a 2 outside the square root, because the square root of 4 is 2. And then 6 doesn't simplify any further, so that will be our answer there. Over here, so we'll subtract the 13 to, the next step would be divide by the -4. So that'll get us with 13 over 4. Take the square root of both sides. Don't forget your plus or minus. Now we can break apart our square roots. And in this case, we are lucky because our denominator, root 4, is just the same thing as 2. And since we do have a whole number in our denominator, we are good from there. We do not need to rationalize.